Hi, everyone. Thanks for tuning in to the Printed Circuit Podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez. In this episode, we'll focus on rigid flex design. I'm extremely excited about this specific episode because here to join me in this discussion is my dear friend and one of today's industry leaders, Tara Dunn, Director of Training and Education for SMTA. Thanks for being here, Tara.
Thanks for having me.
Can you give our audience a brief introduction of yourself and your background?
Sure. As you mentioned, I am Tara Dunn with SMTA. My role there is Director of Training and Education. And prior to that role, my primary background has been in industry, printed circuit board fabrication, starting out in printed circuit board manufacturing, as well as a manufacturer's rep focused on printed circuit board fabrication and working with designers to help solve some of those challenges.
I also want to make sure that we mention, too, that for quite a while, you were a featured column writer in Flex 007 magazine. So I definitely want to bring that up because that's extremely relevant to our topic. And I know for a long time, not just your column, but the Flex 007 magazine from iConnect 007, it's great industry content. So I definitely want to throw a shout out to iConnect and the Flex 007 team. So Tara, what's your history working with rigid flex design?
So Tev, I don't know if I even shared this story with you, but I am here like most people, almost unintentionally in the printed circuit board industry.
Oh, yeah.
That's a question I like to ask when I meet people. So I started in the industry right out of college, but I do not have an engineering degree. I have an economics degree and an industrial relations degree. And as I was looking for my first great job out of college, there was a flexible circuit manufacturer not that far from my house that was looking for somebody to do accounting and human resources. So it kind of was a good fit. The only problem is I barely knew a circuit board, much less what a flexible circuit was. So that actually ended up being a blessing that they took a chance on me for that position, because as part of my training, so I could understand the product better and what I would be paying for through accounting and things like that, they had me work on the production floor for quite a while.
Wow.
I don't know if I thought it was great in that moment, but I thought I was going to be doing accounting. But I ran through all of the different processes, drilling, imaging, all the wet processes, final inspection, all the things, and really got to spend a lot of time talking to people and asking questions as I was learning the processes and all the materials that went into the processes. So, like I said, in hindsight, that's one of the best things that happened as far as being able to start with a strong base for manufacturing circuit boards and all the processes and things that were involved with that.
That's a great story. As you progress in your maturity as a designer, the business side of the industry has to come into play, or you've got to learn about that and add that as a designer, because time is money, and schedule and the whole bit comes into play when you talk about designing boards. And with your economics background and the business background, that helps a lot, especially as you progress in your career. And I definitely want to mention that. So that's a great story you have. I love it. Another question I want to ask you is, can you highlight some of the challenges you might have experienced when designing flex or rigid flex design?
I think one of the biggest challenges with flex is it's very similar to anything that you're doing in rigid board design, but it's just different enough that it's easy to trip up by not paying attention to the specific details.
Early in my career, flex was definitely like a black magic. It was kind of like there was not enough people who knew a lot about it, and the fabricators getting in sync with them and knowing what to do and how to do it, or even when to implement flex or rigid flex in your design. So people just stick to the standard connectors and when connecting boards together and shying away from that.
Exactly. You use the phrase black magic, which is really funny because that's a quote that I use in a lot of my presentations from the design engineering manager from one of the large DoD primes. But his quote was just that. Flex and rigid flex is the black magic of the industry. And what he meant by that was with files and a little bit of nudging on materials, he could get a rigid board built. But with flex and rigid flex, that communication piece is so much more important.
It is. And with the way technology is coming or unfolding, every day it's evolving and getting more advanced, more complex. Collaborating with the supplier, and more so because you come from that supplier side of the fence, collaborating with them early at the beginning stages of design is key. I mean, whether you're doing standard through hole or you're doing HDI, flex, rigid flex, and even now, the hot topic, which I'll just mention real quick, but I'll give you time to talk about the SMTA Ultra HCI event we had. You got to collaborate with the supplier sooner. And so I couldn't agree with you more, in that regard.
Talking about that collaboration, it's so important on so many different things. I think about flex circuit materials or rigid flex materials, and On the surface, if you look at them on the polyimides, there's two different types, adhesive based and adhesive-less. And it's really easy to listen to somebody like me giving a presentation saying that adhesive based materials are less expensive, they're for lower layer count. That's what you should use if cost is a factor, and cost is always a factor.
It is. And then, am I designing it right? Am I using, staggered routing or I-beam routing? What is the bend radius? How tight can I go? There's so many factors that come into play. Just because you can design it on your computer doesn't mean that it's great for DFM. So with that said, DFM, let me just ask, when it comes to manufacturing rigid flex PCBs, it requires specialized process and equipment. How would you propose engineering should account for their design in the design process?
The very key thing to be able to do, and not to sound glib about it, right, but is to understand it and learn it. So you're really understanding what the fabricator's processes are. Some of those special processes include things like when you're running the rigid layers, you're running the flex layers through the same piece of etching equipment, same plating equipment, right? They're very thin pieces of material now running what are through our standard rigid processes. So fabricators have to do a lot of different things. They have to tape leader boards before they enter the machine, tape leader boards afterwards, untape it. All of that causes an opportunity for scrap. They try to, and do very well, accommodate that in the way that they set up their manufacturing panel. But if you can avoid having key areas right at the edges of that panel, that can go a long way to improving your yield and things like that, just by taking into account some of those special processes they have to do. Same with, I think, drilling cover lay. We're all used to printed circuit board, photo imageable cover lay, all the green coating on the square things, that we do. And there's a version of that for flexible circuits, but it's got limited use. It's got to be thinner coppers and low flex counts. Other than that, the process is drilling. So drilling round openings to put over square pads, another special process for flex that you just have to take into consideration.
There's a lot of details here. And I think one of the biggest things that I will always say to any designer at Double E is get your butt down there to a fab shop, walk the floor, and see the intricate details that go into it, especially when it comes to flex and rigid flex design. It's amazing what you will realize and what you'll learn, on the shop floor. Then you can take it back to the engineering when you get into it to really implement. So you're designing correct by construction and not just throwing over the fence and hoping that it works. So Tara, can you share with me any real project examples in which rigid flex was preferred approach versus a standard connector, board-to-board connector? Because that's always been a question that's asked, and recently it was asked, in one of our LinkedIn Live events that Gregory Beers and I did on rigid flex. And somebody asked, when should I implement, or how do I know when to implement a rigid flex versus just using board-to-board connectors?
It's a great question, and I think there's a lot of gray area with it. Because in the right circumstance, a rigid flex would probably always be preferred over that process, because you get to marry the benefits of both. Very tight circuit density on the rigid section with the flexibility of the flexible tails and things like that. But cost is important too. So I think that there's a cost justification to be done there. And I could talk about that for a really long time, because it's not just the cost of the rigid flex versus the boards and the connectors, right? There's a lot of hidden costs in that. But also, us as consumers are driving electronics into being smaller, faster. We want to hold them in our hands. We want them to be more functional in their same size. All those things are converging, and so many applications are at a tipping point where it just becomes the right technology to use.
And I agree with you. I think when it comes to your system's performance, when I say system, I mean, it could think about rigid flex. The reason you'd have rigid flex is because you got multiple boards and you've eliminated a connector. So therefore, you got the connections between the two rigid sides. And when you think about that, we definitely have to consider that, as well as the performance, the signal integrity, the heat, power. How are you addressing that? And then you have the trade-offs when it comes to the cost. And I would like you to elaborate more on that, because that is one of the key factors that always come into play. And a lot of people want to know, what is it going to cost me? What is the cost to jump to that level? Or what is the cost? And very simple, like, I relate it to like when someone says, well, if I add 2 more layers, what is the cost? If I use an 8-layer or 6-layer board or a 10-layer board, what is the cost difference? Well, what is the cost from standard versus rigid flex? I would like you to elaborate more on that, if you could.
Sure, I can. It's a really common thing to have happen when people compare it. So first of all, rigid flex is more expensive than rigid processing. That's just the fact. There's no dispute that there. But then when you start looking beyond that to some of the other costs, so it's very common for somebody maybe purchasing or making these decisions to look at the cost of the rigid boards, the cost of the connectors, and then the cost of the rigid flex, and then choosing the circuit boards and the connector. But you have to look at it more holistically, in my opinion, because it's also the cost of issuing all those purchase orders. It's the cost of receiving all of those different pieces of material, the cost of assembling all those different pieces of material, the yield loss that's associated with any of that kind of a process versus a rigid flex where you receive it, you order it, you receive it, inspect it, install it, right? It's a very different process. And so you have to take all those residual costs too into consideration before you make those decisions.
This is where going back and collaborating with your supplier early on is key. So you have that, what I call like supply chain intelligence at the point of design. We use that a lot, especially coming out of COVID, as we think about how things are coming or things are unfolding in industry. So, but when I think about rigid flex, I think about saving space if I'm eliminating connectors, which I come from the mil-aero world, and also reducing weight in the overall size of it. For example, what I'm holding in my hand is a system. I know in the podcast we can't see it, but as I'm holding this system in my hand, it has rigid flex that allows me to make something really small and condensed and lighter weight because I don't have these bulking connectors that I need to connect from one board to another. So could you elaborate on that as well?
Oh yeah, it's one of the great benefits of the flexible materials is the space, weight, packaging. There's just no denying the benefits of that. You'll be able to go around corners, fold around different areas.
It's a lot. You're exactly right. And when you think about, do I do a loose leaf or is it just, one book bind? How there's so many different caveats or different flavors. Do I have cutouts or how do I design? Do I need to add stiffeners to it? Do I need to have tear reliefs? What about my anchor points on the pads? There's so many different things that have to be addressed or how to address it or what happens when you don't do it and you design flex in a standard methodology.
And then you get the flex that doesn't flex when you're done.
Yes.
Been there, done that a few times.
Yes, I can attest to that. I can attest to where our radius, typically you want like a 12-to-1 or within that range from your board thickness, and it's too tight, it's too stiff. And you have to think about, is this a dynamic flex or static flex? We talked about that, like I said, in that LinkedIn Live event. And you have to know these requirements going into design. And this is where, again, working with your fabricator is key on that, to know what your outcome is and what you need to design and how to design it correctly, because you definitely want to make sure you're including the DFM into the design, which you and we've talked at length about that.
And not just the standard, run it through the design rule check, but if you can communicate with your fabricator on how it's bending and folding in use, and that's a more difficult thing to communicate.
It is. You're exactly right. You're exactly right. And this is where having these in-depth meetings and visually showing, okay, this is the widget we're trying to design, and this is the envelope and where it's got to go, and this is how it's connecting to the outside world. It's key. It's key. And I can tell you there, and I think you would agree from me, especially coming from the supply side, is that most suppliers will bend over backwards, literally bend. We're talking about flex. That's my little, they'll literally jump through hoops to help you be successful with your design, to provide you that expertise input. When I think about flex in especially like now that I'm seasoned, very experienced with designing boards, I think about young designers and where do they get this knowledge? So from your perspective, how does a printed circuit engineer continue to evolve or develop rigid flex design skill set when it comes to their continued education and development?
That's a good question. And I think the overarching answer I have to that is to be intentional about it. There's so many resources, right? We have the free resources that you can find, whether that's working through associations such as SMTA or PCEA. So much information available there. Fabricators generally all have webinars, easy enough to tune in and learn a tip or a trick here and there. There's books, print books. There's a lot of ebooks that have a lot of good information. Magazine, industry magazine columns. I wrote for iConnect for several years, doing a column on flex and rigid flex. Great resource there. There's podcasts such as yours that bring information all together. And, one thing I want to say, I touched on associations just a little bit, but I think you can attest to from the PCEA side of it, is when you're finding information. It's really easy to go just Google it or go on YouTube and find a video. And that's great. There's a lot of good information out there. But when you get information from associations through their webinars and things like that, they're already vetted, right? They're vetted for commercialization, they're vetted for accuracy. Same with most of the ebooks out there that are published through places like iConnect and others. So I think that that's an important caveat to keep in mind, is where you're getting your source of information.
And I'm glad you mentioned about the ebooks, because iConnect, and I always refer to them because they're the first association that comes to mind when it comes to, or magazine that comes to mind when it comes to the ebooks, is what they're producing of the different spectrum for printed circuit engineering. Their ebooks are amazing. I like them that they're not really long, several hundred pages. They're relatively short, but the content is so good and it's simplistic and to the point. I really like those ebooks. But there's, like you said, a lot of suppliers are producing ebooks and they're producing content. And what's good is that about them doing that is that it's coming from a known source. Like you said, there's a lot of stuff out there on the internet that you can Google and find content, but how well do you know the source where it came from? And is it validated? Is it proven? Or is it just somebody wanting to produce something on the internet? Now, as much as there's good content out there, there's several times more, a lot more that is not good. I won't say bad, I'll just say not good content. You and I talk about that, especially, with our affiliations with SMTA and PCA, and how we're collaborating and how we're doing our best to give back to the industry and passing on these golden nuggets of content for the printed circuit engineering industry. And its key is to know the source of where you're getting this information from. I'll mention like American Standards and NCAB Group, and Sanmina, they and TTMs, they do a lot of great stuff regarding the content that they produce so you can go as a designer, go and download to their website. There's a lot of stuff that's good. It's really good and it's viable.
And I think that blends into something else I wanted to point out too, is building your network as you're continuing your education. I know, Steph, you do a lot of work on expanding your network, connecting with people and across the industry, right? And I think that's so important. And I think for two things. First of all, when you're looking at some of that content that we just discussed, those people that are putting out good content are industry experts that are giving back to the industry and want to share. So they're great people to contact and ask specific questions if you don't get it just out of that 30-minute webinar or something.
I couldn't agree with you more.
Yeah, it's a great, I think it's an often overlooked resource, is the authors of some of these things or the presenters.
The two magazines, which is any of the iConnect 007 magazines, as well as the printed circuit design and fabrication that we produce with PCA, the authors that produce content in there, the column writers and stuff, what I love about those professionals or those individuals is that you can email them and they will respond to you. These are people that you want to add to your professional network, like you said. And, like you and I were just last week, we were at the SMTA event in Peoria. That was awesome. On the HCI, by the way, congratulates to you and the team there, the SMTA team, for putting that on. Amazing show. I can't wait for next year for that. But there's a lot of collaboration and a lot of networking of sharing this best practices and knowledge as the industry unfolds. And how do we get to that next level? And we don't do it alone. I'll tell you that. It's about collaboration. And for the younger generation, you want to expand your career, you have to establish and continuously evolve your professional network. That's what helped me. When I got involved with IBC way back in like 2003, 2004, it made all the difference. And I look back from where I started and where I came today, a lot of it has to do with networking and getting involved with industry associations like SMTA, PCA, and IPC. IPC is amazing too. I love the IPC stuff. There's a lot out there. So as a subject matter expert, what is some of the advice you would give to the new generation just getting started in this career about approaching rigid flex design?
So the number one piece of advice I always give is networking, making sure you know the right people to reach out to. But since we've already just talked about that, the other thing that I would think is important for people to know as they start working with flex and rigid flex is that everyone's on a learning curve. I know it can feel like you're starting something new and, oh my gosh, how am I going to learn this? I'm going to make mistakes, but everybody is. That could be the person that's going from rigid to complex HDI or rigid to rigid flex, or now with the ultra HDI, everybody's on a learning curve. It doesn't matter if you've been in the industry for 65 years, you're still going through a learning curve right now, right? As we're learning additive processes and new materials and how to fabricate them and how to assemble them. So I think it's important to take some of that pressure off that there's going to be mistakes made. It's typical with Flex and Rigid Flex that you're going to run that prototype cycle a few more times than you would typically expect on a rigid type design. And there's a lot going on. It's not just you're designing it in 2D. And all the great 3D models, they're so helpful, but they can't predict everything that's happening in the field.
Correct. Especially when you take a rigid flex design and you put it through like a Mil-Aero certification that does HASS and HALT testing, that you have the shake and bake. And that's where you truly find out, did I design for manufacturability correctly? Not only did I design it correctly, but can it be manufacturable? And is it going to work in the environment in which I designed it for? So with that, Tara, we're running short on time here. It was amazing. And I want to thank you for having the time today and spend with us. So thanks for sharing your insights and experience with us on the Rigid Flex design. Because it's a lot of content when you think about Rigid Flex design.
Yeah, it's a big topic. But thank you for having me. It's been a fun discussion.
Awesome. And to our audience, continue to tune in for more trends, challenges, and opportunities across the printed circuit engineering industry.